And next is the periodic and aperiodic signal. So periodic signal is nothing but if we are saying any signal is a periodic one if it exhibits symmetry, right? So x of t is equal to x of t plus capital T. So you should be very careful with the cases of the signals representation here. So here x t or here small letter, and this side we are having x of t plus t. This t is the capital letter. And similarly in the discrete domain, x of n is equal to x of n plus capital N. And here this t, capital T and capital N are used to represent the period of the signal. So x of t is equal to x of t plus t at any period, right? So if it is my second cycle, or if it is my third cycle or fourth cycle or nth cycle, whatever may be, my signal will be equivalent to my x of t signal. That is with the first cycle or zeroth cycle. If you are saying here t is equal to 0, the initial value, right? Initial cycle. So that will be equal to the signal at any cycle time period. And similarly here also x of n is equal to x of n plus capital N. And if it is a periodic signal, it is not satisfying this condition. If the condition is not satisfied, then we can say our signal is a aperiodic signal. So x of t is not equal to x of t plus t, and x of n is not equal to x of n plus n. That is, we cannot have the same signal at a different cycle, in the different cycle. That is the case. So in that condition, under this scenario, we call that kind of signals or aperiodic signal. And coming to the next one here, the important condition for the periodicity. So x of n is equal to x of n plus n. For satisfying this above condition, the frequency of the discrete time signal should be the ratio of two integers. So k divided by n. So you can